All right, so here is an overview of the real number system. There are several categories, as you can see on the screen. The entire screen will consist of real numbers. So in the top right here, I wrote real numbers, and everything we go over here is going to be considered a real number. So every category here you see is within the real number system. First, we're going to start with, on the left side, with the smallest box. That's natural numbers. Natural numbers are all positive numbers. They are, examples would be like 1, 2, 3, 4, and so on. So they can't be decimals or fractions. It cannot be zero or negative numbers, but any positive numbers. All right, now whole numbers. Whole numbers are similar to natural numbers, but they also include zero. So examples of whole numbers would be 0, 1, 58, 142. Those are all whole numbers. They cannot be negative, but they do, and they cannot be decimals or fractions, but they do include zero. So 0 is considered a whole number, but not a natural number. Okay, so for integers, the next box, integers include all whole numbers and natural numbers, but they also include negative numbers. So you can have -3, -8, -42. You can also have 0 and any positive numbers like 34, 503. Those are all integers. They still cannot be decimals or fractions, but they include negative numbers as well. All right, and then the final big box that includes integers, whole numbers, natural numbers is called rational numbers. Rational numbers, again, they include the three smaller boxes categories, but they also include some decimals and fractions. So if you can write a number as a fraction, it is a rational number. So for example, the number 4. I can write that as a fraction 4 over 1, and therefore it's considered a rational number. Decimals, if you can write a decimal as a fraction, it's considered a rational number. So for example, the decimal, I'll write it over here, 0.4. 0.4, that's 4/10 if you were to say it as a fraction. And therefore, if you can write that as a fraction, therefore it's considered a rational number. Another one that can be tricky for rational numbers, you can also have, and I'll write it kind of sideways here, but you can have decimals that are repeating, like 3.2, oops. Hold on. Okay, so you can have something like 3.2 with the line over the 2. And you can see that line over the 2, if you don't know what that means that 2 is going to be repeating forever. So they call those repeating decimals. And you can, we're not going to go into depth on how, but you can actually write repeating decimals as fractions. And therefore, that repeating decimal of 3.22222 is considered a rational number. All right. So some other examples are right here. You could have, let's do 1/3. That's a fraction, so it's a rational number. 0.314. So if you have a decimal that terminates, a terminating decimal means it ends. It doesn't go on forever with random digits forever. Then that is considered also a rational number. So 3.14, it stops after 4, and therefore it's a rational number. Now, you see on the right side of the screen, the last category we're going to cover today is irrational numbers. Irrational numbers does not include and is not a part of any of those other categories we've talked about. And an irrational number, an example would be pi. So there's the pi symbol. Pi, if you're familiar with it, is a number that's always 3.14, and then it goes on forever with random digits. It has no pattern. That's the key with irrational numbers, is that there is no pattern with the decimal that goes on forever. So if you have a decimal that goes on forever with no pattern, no repeating pattern, then it is an irrational number. Another example might be 4.21633 3, 2, 4, 9, and just keeps going. So if you just have a decimal like that just keeps going and goes on forever with no apparent pattern, repeating pattern, it is an irrational number. And that's the difference between that and rational numbers. Rational numbers, you can have a decimal, and in some cases a decimal that goes on forever, but if it's a rational number, it means it has a repeating pattern. So that is an overview of the real number system. And check out, I have another, if you want more examples, I will give another video on examples of the real number system.